Hey everyone, we are back. We are the Breakpoint Show. It's great to have everyone back. As you can see, we are filling up the whole screen today because, well, if you're watching this on YouTube, we are filling up the whole screen, and you should watch it on YouTube. We're three very good-looking gentlemen. But I joke, but I always say I have a face for podcasting, and I have for the last almost 20 years. But yeah, so we have our guest Mark Rendle, who we will introduce in just a few minutes. But I wanted to say hi to Khalid and Martin. How are you guys doing?
Yeah, we're doing good. I mean, I will say, as an American, daylight savings time is really messing with me this week. So if I feel low energy, blame it on the time zones.
Well, I actually like it because
how dare you?
Yeah, I know. But I wish we didn't do it at all. But at least the positive is the sun goes down a little later in the evening, so I can do a few more things outside, take the dog for a walk later in the evening, stuff like that. So, but yeah, it's not great when you have to start going, okay, what time is it in other places of the world? Because now that things shift an hour, because we're very important people to have friends in other places, we do. But Martin, everything good over in Belgium?
Yeah. We have another 2 weeks before we make the transition in terms of time. So I will be the one complaining on our next recording.
Yeah, isn't that weird that people do it at different times and stuff like that? So, well, okay. Well, let's just jump right into it. Mark, it's great to have you on the show. You're the first guest of the show.
I am honored.
Yeah. So before the show, I told the guys that when I have questions about .NET and C#, and I have quite a few, these are the three people I usually come to, because if one of these three people don't know what I'm asking, probably 99.9% of the rest of the .NET community may not know. So Mark, introduce yourself.
Hi, I'm Mark Rendle. I've been a .NET developer for as long as it is possible to have been a .NET developer, which is still not enough experience for some agencies, but you know. And I am these days. I work as a sort of consultant or senior sort of lead architect dev kind of thing, and I work with lots of companies. Particularly where performance is an issue, and we'll get into what kind of performance issues people have. And also I charge around the world speaking at conferences, and I play bass with Dylan Beatty and the Line Breakers, which is a new thing, which is awesome fun. And yeah, I am basically just living my best life, and I am a very lucky man.
Awesome. So the topic today is going to be performance, and we have this little competition that's going on across all of the different communities in our kind of software development space. And do you want to describe the competition, Mark?
Yeah, sure. The competition is called the 1 billion row challenge. And it was kicked off initially by a Java developer. And essentially it is, you have a UTF-8 text file, and it has 1 billion lines in it. And each line is the name of a weather station, and then a semicolon, and then a floating point number, which can be positive or negative. And there's about 420 different weather stations. and multiple measurements for each of them. So assume the measurement is temperature or something. And so the challenge is write a program that parses the entire file and calculates the minimum, maximum, and mean temperature for each weather station, and then just dumps it out, prints it out to the console. And it's how fast can you do that? And it's a really interesting challenge. And the thing I really like about it is it's actually quite, you see competitions like this and there's no real world use for what you're doing, but actually parsing a file like this in the quickest time possible, there's lots of situations where that's a useful thing to be able to do in a production environment. So yeah, and I happen to be between jobs right at the moment. Hopefully got something lined up in the next couple of weeks, but I am kicking around and doing my own thing. I'm working on a high performance .NET workshop, 2-day workshop that I do at NDC conferences and privately, and also putting together a video course. And so this kind of feeds into both of those things as well.
Very cool. Yeah. I mean, just kind of from a high level, did you feel starting this 1 billion row challenge with .NET, did you feel like .NET was capable of kind of meeting the challenge, or were you a little nervous about, the performance profile of .NET going into this?
I'm using .NET 8, and so I wasn't worried about it. It's kind of, there's the standard C# programmer thing of if Java can do it, I can do it. But no, that Microsoft have invested so much in performance, both in terms of the runtime, but also C# over the last, since we went to .NET Core and .NET Core 2.1 introduced a whole bunch of things, and they're adding these things to the framework because they need them for building ASP.NET Core, for example. The people who work on that contribute a lot of performance pull requests to the runtime so that they can make ASP.NET Core faster. And then you've got all the Microsoft teams who are out there building whatever they're building on .NET, like Bing and event hubs and all these sorts of things. And so, yeah, Microsoft have done this huge investment, and it's made it much easier to actually write and optimize this kind of thing.
Yeah, I guess the reason I ask is because, like, infamously, I guess a few months ago, Microsoft put out like a job post where they're rewriting things from C# over to Rust. And Chris will put this in the show notes, but in the 1 billion row challenge site, we see other languages and other tech stacks like Java, C++, Python, Go, even JavaScript, and Rust famously here, which is known for memory safety and performance. So it kind of feels like we as a .NET community are kind of being left out of this challenge. But like you've mentioned, there's really nothing in .NET that keeps us from doing high performance implementations. No. And we've seen it also just looking at people doing this in .NET, hitting kind of similar performance profiles as kind of these other things. So
yes. Yeah, no, I don't. I mean, the 1brc.dev site has Zig on it, which is kind of like the new hotness, the high performance language that's easier than Rust. But yeah, I also don't see your favorite language listed above. Open an issue to add it, so I will do that after we have finished recording.
Which, Mark, by the way, you may also want to do for PHP. I saw a blog post over the weekend of someone trying the challenge in PHP, which was impressive because the initial baseline was very, very, very slow.
Yeah,
and the optimized version is not that fast, but it's
a lot faster,
a massive factor faster than the original one, and
yeah.
It almost boils down to the same things that are happening in our languages, taking the same techniques, taking the same approach in terms of multi-threading or coroutines or something like that.
Yeah.
But that's also fascinating in a way that seeing all of those languages being the same performance profile, it's fascinating to see that every single ecosystem is investing in that, and the performance and also the optimizations that the compilers all do are very, very similar.
Yeah.
Yes. Yeah.
So just to kind of jump right in, where in the CLR in the framework, so this is .NET Core and stuff, C# 12, where did you kind of have to fine tune and go beyond the framework?
So, I mean, if I go through the process of sort of writing this, you start off with a baseline where you just do, if I was going to run this once and I really didn't need to worry about it, how would I do this? And so you use a stream reader, which returns you a string at a time for each line. And then you call split on the semicolon, which gives you 2 strings. And then you do float.parse on the second string, and then you use the first string as the key into a dictionary. And then you see how long that takes, and it's a little over 2 minutes. And you can then get into profiling if you want to. You can sort of crack out .memory and .trace and these sorts of things. But actually, from years of experience, you know up front that one of the biggest things that's hitting that is for every single, so for 1 billion lines, you create 1 string, then you create an array with 2 more strings in it. And so then that's 4 allocations. And 4 billion allocations is working the garbage collector quite hard. None of them are long-lived, none of them are going into Gen 1, but you're allocating 4 billion objects on the heap, and the garbage collector has to run around after you and clean those up. So you see lots of GC cycles. So then you kind of go, okay, if I don't do the string.split and I don't create the array, so I just have a string for each line and I just find the index of the semicolon and substring and maybe change the string into a read-only span of char. And so that works as well. And then you get to the point where you're going, well, if I'm working with read-only spans of chars, and this is UTF-8 text, then I can work with read-only spans of byte instead. And that's where you start getting into the sort of lower level stuff. So I started out, my sort of early optimization was I switched from using, I didn't even use streams at all. There is the safe file handle type. And in .NET, I think it was in .NET 6, they introduced the random access type, which has a bunch of static methods. You pass a safe file handle, and it will just, from anywhere in a file, jumping around backwards and forwards, that sort of thing, it will just read and copy things into memory. And so that was and that took me down to sort of 10 seconds. No, that took me down to under a minute. And then you kind of like, okay, so, and I'm doing the minimum possible. But because I've got a dictionary of string, comma, counter, I am still having to turn that first bit into a string so that I can use it to get the value out of the dictionary, increment it, and put it back into the dictionary. And so that's not good. And then you start looking at, well, what else could I do with the first however many bytes it is up to the semicolon in order to avoid that string allocation? And so you write your own hash algorithm that will essentially take the first 8 bytes, having checked that that will be unique within the names. And you can just say, okay, those aren't 8 bytes, those are a long. And .NET goes, yep, all right, that's a long. And now we can use that as the key on our dictionary. And so that gets rid of 1 billion allocations, and that was a big speed up. And then we got to the point where we're running this on a single thread. Okay. And so then you want to go, okay, let's multi-thread it. And then that obviously chops your runtime down by, divide it by the number of processors you've got in your machine, which is 16 in my case. And at that point, I think I was down to kind of sub 10 seconds. And then it was really looking around for what else is there in .NET that lets us avoid allocations and avoid as many operations as possible. And so, yeah, I went digging and I found some interesting things.
Cool.
Yeah. You talking about it, like strings are always the number one problem that you see with like memory issues. And you talked about this idea of like, if you're going to do it one time, you can just optimize. And in this case, the challenge is to optimize for speed. I do know in like later versions of .NET, you can actually change out the garbage collector. So I'm curious if anyone's tried just disabling the garbage collector. Do you know what I mean? Like that could probably be something like, okay, we just don't do garbage collection. Your memory might go out of control, but you get the speed.
You would hit a point on most machines if you turned off garbage collection where you literally ran out of physical memory, and then it would be going to the swap file, and then that would be slowing things down again anyway. So
exactly. So that brings up a whole different point. You have all these different people that are working on this competition, and you have probably what i9.
I have a Ryzen 5950X.
50. Okay. Well, what if I have what's the Ripper? What's the other AMD?
The Threadripper.
The Threadripper that could get like what's the newest one? It could be like 196 or
28 like or something. They got a lot.
Yeah, it's like 100. I think it might be up to like 140 something threads that you can have at once. I mean, you put that in like 256 gig of RAM. Anyone can burn through 1 billion rows. So my question is, how do you kind of rank yourself with people that have different hardware configurations?
So at the point where I want to do that, I will open a pull request and add my solution to the official thing, and then they use a specific VM. I don't know if it's a physical machine or if they use a cloud instance, but essentially they run them all on the same hardware, same operating system.
Okay.
And actually, if I do that, I'm going to have to turn on the native AOT compilation because they actually include the startup time. And at the moment, I've just been measuring once it's started, how long does it take? But so native AOT is definitely in the future for this.
Mm-hmm. Oh, and that's Martin's favorite topic. He loves that topic.
It's a super interesting topic, and I think that's essentially what I mentioned earlier, where all of the runtimes, if you look at the Java results, for example, all of the native AOT comparable solutions in those languages are performing, or at least in the top 5 of best performance.
Yeah, because it includes that JIT time, and so all the Java applications, I think all the Java applications in the top 20 are using Graal VM and then using that to generate a native executable.
Mm-hmm. Yeah, they're also using a lot of unsafe code, meaning like there is a chance that things blow up because there's just no checks on memory or stuff like that. So like I know we have unsafe code in C# and .NET, and I've seen a couple samples where folks have done that. So that could be another option for folks. So
yes. So one of the things that I found interesting looking at the other solutions, not just in Java, I looked at one in F# and a few others, and essentially so once I was down at that point, excuse me, the next operation, the next optimization that I went for was switch from reading the file into memory to just opening it as a memory mapped file, which is a feature that's built into the kernels of operating systems. They all have it. You can do it on all of them. And it essentially doesn't matter how big the file is, it presents it to you as though it were memory, and you can hop around in it by incrementing, decrementing pointers. And so all the super fast solutions are using this way of accessing the file, but the majority of them are essentially doing native pointer things. And it's all completely unsafe code. And this is something where .NET actually, they wanted a way for us to be able to write the kind of code that we would have used unsafe for, but not to have to be unsafe. And so that's what the system.buffers and span type are all about. Span it's many things, but it's a wrapper around unsafe code that you can then use without having to mark your own code as unsafe. And a lot of places are completely happy to take a dependency on a library that's probably got unsafe in it all over the place. But I've worked in places where you couldn't even commit. They had a commit hook that just looked for the word unsafe in your code. It wasn't sophisticated. If you happen to say, don't click this button, it's unsafe in a message box, that would trigger it. But yeah. And so Span lets you write this kind of level of performance of code, but without needing the unsafe blocks. And so, yeah, with a memory mapped file in .NET, you do have to do one thing that has to be marked as unsafe. So you can sort of, there's the out of the box built in ways of reading things from the file, but they are not, they're not performant enough for this. What you can do is you can create a view over the memory mapped file, and then you can say, hey, just give me the pointer. Just give me the pointer to the first byte where it is in memory. And that is an unsafe operation because you have a asterisk byte pointer to that position. And so I grab that, and then I can use that to new up a span. I can just pass that pointer and the total size of the file into a span byte constructor. And then now I've got a span and I can do all the span things, and the performance on it is ridiculous. And one of the differences between my implementation that has enabled is the ones, they are reading a byte at a time and saying, you know, if we're reading the key, then add it to the key. Otherwise, if we're on a semicolon, then we're not reading the key anymore. Now we're reading a float and all this sort of stuff. Whereas I can get my span and then I can break the line into a slice of that span, and then I can find the index of the semicolon, and then I can create two more slices, one with the key, one with the float. And it makes your code easier to reason about. It makes it easier. I suspect I will come back to this in sort of 6 months, and I will probably go, I don't understand what's going on here, but I think it'll take me less time to figure it out than it would if I was just doing raw pointer arithmetic all over the place.
Yeah, I've been trying to learn Rust right now, and yeah, it's a lot of pointers and memory management and stuff like that. I'm like, oh my god.
Yeah.
So, yep. Martin, you have a question, don't you?
I do have a question. Actually, I wanna give Chris a challenge on this. Our previous episode was on databases and storing data and so on. And all this talk about importing data, doing averages and minimum, mean, maximum, all of that stuff, kind of made me think about, okay, a database would be a good approach to solve this challenge, right? Import a CSV file into the database and then run all the queries you want. So Chris, if you're up for it, I think this would be a really nice challenge to just read that data file into SQL Server and see if that stacks up against all of the custom solutions out there.
Probably wouldn't. I mean, it might, but I would probably, seeing some tweets that Mark has done, that has pushed out over the last couple of days. I mean, it's interesting. It would be interesting to do this with to see the performance for Entity Framework Core versus Dapper versus native data sets and stuff like that. So maybe I'll take it and make a whole new challenge for the database side. But Mark, you actually created your own floating floating
floating point parser.
Yeah.
So this was when I got it down to the 5-second mark, and then I started profiling. I started using .trace to see which methods were taking the longest time, and I was very surprised to see float.tryparse was in there. And so it's kind of like, well, how do you parse a number when it's coming in as UTF-8 bytes? So the neat thing about UTF-8, and you really do have to get into worrying about things like encodings when you're doing this sort of thing. But the neat thing about UTF-8 is that the first 128 ASCII characters are represented just as the ASCII character. And then everything from then on. So essentially, for the ASCII characters, the highest bit is not set. So they all start with 0. And then all the other characters guaranteed to start with a 1. And so if you do index of 10 into that, you are guaranteed that it's new line and not half of a UTF-16 character or something. If you do this with UTF-16, it won't work. It will see a byte with a value of 10, but that is actually half of a character. And so UTF-8 lets you do this sort of thing. And so the digits 0 to 9 and the minus sign and the period character are all in those quick things. And so you can buzz through it very quickly. And so take the first byte, and if it's a minus, then set a multiplier to -1 that you can use at the end. Then take the next byte, subtract the ASCII value for 0 from that byte. I think it's either 48 or 49. I tend to, anytime I actually need kind of like a constant byte version of the ASCII thing, I just use the char and cast it to byte because that's much easier and makes more sense. Mm-hmm. And then you keep going along, multiplying by 10, and you hit the decimal point. And then you start doing it with the fraction number. And then you just add those two things together to create your floating point number. And that is faster than float.tryparse. I don't know how float.tryparse works, but what I do know is that for the 1 billion row challenge, we are not writing production quality code. We're not doing any checking of anything. We're just going, okay, this file follows these rules. Each number has 3 decimal places, even if it's 0, 0, 0, and all this sort of thing. And there's still some optimizations I can do based on that. The next thing I want to try is, and I'm pretty sure this will make a difference, let's not pass it as a float and store it as a float when we're doing the min, max, mean, and all that sort of thing. Let's work with integers, probably longs, but yeah. And then when we get to the point of displaying it to the screen, just divide everything by 1,000. Mm-hmm. So yeah, that's the next thing to try, because obviously floating point operations are more expensive than integer operations, or that's my working theory anyway.
Yeah, you said something really interesting, right? This challenge and kind of the mindset that you went into this challenge with is I'm not writing production ready code, but kind of as you were going through this and writing and iterating over your solution, what do you think some takeaways for you from this challenge that you can kind of take into a production environment or a business scenario that you can now apply because you went through this challenge?
So definitely this notion of using memory mapped files is, yeah, that's a massive performance boost. And yeah, if you're working when you're working with big data files, and I quite often deal with that sort of thing. My last job, we had multi-gigabyte files that were landing from external partners, and you need to get that passed and get it into a database as quickly as possible. And I did that at the time using the file handle and random access approach. And so I would go back and I would redo that using a memory mapped file. And then there are other things. It's kind of, I knew a lot of this stuff going in, but it definitely, for other people looking at the solution, and I'm going to write some blog posts about it and sort of explain all the things. There's some really useful stuff about threading. So this is a CPU intensive task. We've got stuff in memory and we're just parsing it and doing things with it. And so it's all CPU, really. Once you say memory mapped file, IO is taken care of. Everything now is CPU bound. And I've seen some solutions that chunk the file into sort of gigabyte partitions or something, or arbitrary sized partitions, and then I've just fire that off at however many threads are needed for that many partitions. And that actually ends up being slower because you have more threads than you have cores in your processor. And I mean, I've got 16, which weirdly is exactly enough to break it into 1 gigabyte chunks and do it that way. But if I was running on an 8 gig machine, or if this was running in a data center, it might be in a Docker, a Kubernetes pod, or a container that's only allowed 2 gigs of RAM, or sometimes it's half a gig of RAM. And so you need, it only has, we're not talking about RAM, we're talking about CPU cores, but it might only have 1 or 2 or 3 CPU cores. And so you want to divide the overall size of the file by the number of processors you've got, and then kick off that many threads. If you're doing something CPU intensive and you're running it on more threads than you have cores, then you're actually incurring the cost of switching between threads on a core. Every time you do that, it invalidates the core's cache, and so it dumps whatever was in the cache back into memory and then loads the other thread's memory onto the CPU cache. And so that, I think, is one of the things I would like everyone to take away from doing this is, don't run, if you're doing something CPU intensive, don't run more threads than you have cores, because it will just actually slow you down. It's a net loss.
Wow, that's great
that makes
advice.
Me think, Mark, if you do that chunking, would it be better to kind of keep the chunks in a queue somewhere and essentially process them on as many CPUs as you have threads, but still use that chunking mechanism? Would that, in your opinion, make it faster? Would it make it more efficient? Or would that still incur the cost of having CPU caches that need repriming?
It's something I want to try. So there is a negative aspect to that idea of just create as many threads as you have cores and set them all going. And one issue with that is that you may have some cores, because while your computer is running, the CPU is also the operating system's talking to it and saying, hello, could you please scan this file for viruses or sync this Dropbox file or whatever? And you have no control over that. And so you get some cores will finish and go, I'm done. Got anything else for me? And you say no. If you break things down into smaller chunks and put them on some kind of queue, then you effectively implement work stealing. And so if a core finishes early, it can steal the next chunk to be processed. And so that has the potential. And then the question becomes, does the overhead of running that queue and doing the peak and the blocking probably be a blocking collection, simply because you don't want async in this anywhere? And the channels, I love system threading channels, but they are geared towards async. And I don't want to be using async on this. So
I think you would probably want to try something like channels, but then thread oriented instead of async awaits oriented.
Yes. Yeah.
Well, I have one last question. Like throughout this process, you mentioned tooling, .trace, .memory.
Yeah.
Like throughout this process, as you're doing the challenge and experimenting with ideas, do you feel like the .NET space gave you adequate insight into like trying something, measuring it, and then understanding whether you actually made a positive impact or a negative impact?
Yeah, it really did. So there are some things in the .NET space, sort of open source and command line tooling and that sort of thing. So obviously benchmark.net, I use that a lot, just generally day to day. Benchmark.net. So when I was doing like the float parsing, you can say, here is my baseline, here's what I'm doing at the moment, here's a method that I think will be faster, and then benchmark.net will just run those, and it will do sort of warm-up phases and make sure that everything's jitted, and if you've got tiered optimization, then it'll make sure it's hit that point, and then it'll test multiple implementations. That's really useful. That will also show you how much memory was allocated, and there are settings you can apply to, it'll actually dump out the IL code or even the machine code that was generated by the JIT. So you can look right down at the CPU level instructions. So that's really useful. There's also .NET Collect and .NET Trace, which will pick up counters and metadata from a running process. So those are really useful. And I am a big fan of .trace and .memory. And the only downside to that, particularly for workshops, is obviously JetBrains puts a lot of time and effort into building these things and quite enjoy it when people give them money in exchange. And a lot of developers these days seem to have an enormous problem with the idea of paying for tools. And but yes, I think we are very well served. And then I haven't quite got to this point yet, but then there are tools that exist outside of the .NET space, like the perf command line tool, which will actually, it's a Linux feature, and it will tell you, it'll count cache misses, for example. So if a CPU instruction goes to access a bit of memory and it's not in the cache, then that's a cache miss, and you incur the nanoseconds that it takes to copy a chunk of memory from a stick of RAM onto the CPU. But yeah, I think I might get bored before I start worrying about that.
So I'm curious, what before we wrap up, we try to limit this to around 40 minutes for an episode.
Okay, well, can I just have one thing that I just remembered?
Oh, sure, go ahead.
But so I learned about this while doing this challenge. There is a type in .NET. I think the method I'm using was added in .NET 5. But there's a type called collections marshal, which lets you do sort of low-level memory-ish things with the built-in collections. And I knew about it because you can use it to get a span from a list, which is useful for iterating over it because it's much quicker. But there's a method in there called get value ref or add default, and you pass in a dictionary and the key that you want, and then you have an out boolean, and it returns a reference to a value. And if it's not there, it adds it to the dictionary and then it returns a reference to that. And the really cool thing about this is that you can then change that value, and you're changing it actually where it is stored in memory in that dictionary. And so you don't have to go through, if not dictionary.try get value, then add the thing and then set something and then put it back into the dictionary. And so benching that against the naive implementation, that was a pretty big performance improvement as well. So, but yes, cool. The collections Marshall class has got some very helpful stuff in it if you're into this kind of thing.
So please write a blog post about all this, by the way.
I'm going to
read it. Yeah,
please. So for all this multi-threading, I mean, there's native multi-threading, the easy stuff that you get with .NET. I'm assuming you're not using that, or you're you actually are. I didn't know if you were using maybe some open source threading libraries or something, but you're just using the native .NET.
I'm using parallel.forEach. So I create 16 classes, each of which has got a different offset and length that it's supposed to be looking at, and those go into an array. And then I literally just call parallel.forEach and call run on each of them. And I don't know that anyone could do a better job than the parallel task library. It's really rather good. So
that's cool.
I'm trusting that.
That is a unknown. Most developers have no idea about parallel.forEach. How powerful it is.
Yeah. And it's even better now because they recently added async overloads of them as well. So you can pass in funcs that return tasks or value tasks rather than just actions, which it was before, which made it difficult to work with like HTTP client and SQL things.
Cool. So any last questions? Martin, you've been kind of quiet. We'll give you the last question if you have anything.
At this point, I would love for the clocks to go backwards 1 hour so that I get 1 hour to play with this as well.
Yeah, I know. This is really good stuff. So Mark, we appreciate you coming on the show. My mind is very full of stuff. Good stuff, not the
you're
bad
thinking
stuff.
about the SQL Server approach, right?
Yeah. Maybe I'll do a database challenge because it's not SQL Server. It has to be kind of a database and not even a relational database. It could be just any data storage that you want to do. But we'll see. We'll see. I've got so much free time on my hands. With announcing self-publishing a book, I definitely have a lot of free time on my hands.
Absolutely. Yeah, that's the easy bit, isn't it?
Yeah, I have so much time. So but Mark, it was an honor to have you as the first guest on the show.
It was an honor to be the first guest on the show. So thank you very much.
Yeah. And we'll put all this stuff in the show notes. If there's any other links that we have a bunch of links that we're going to put in the show notes, but pass along anything else to me or to the guys.
Okay.
And we'll put whatever you want. But this was a great show. Hopefully people got a lot out of it. And like always, I want to thank the smarter people in the room than me, Khalid and Martin and Mark for making the show great this 2 weeks. We'll see you in another 2 weeks. But again, like the YouTube video,
mash that subscribe button, click the bell.
Subscribe. I'm not really down with the lingo of the YouTubers, but smash the subscribe. We have quite a few subscribers. I'm surprised at our numbers. So I'm just joking. I'm not surprised, but we create a good show. But or just tell your friends about the show, pass this along on all the social networks, and thank you. And if you have new topics or new guests, we will probably do this maybe every couple months. We'll have a new guest on to talk about a subject. It doesn't have to be .NET. It can be anything, really. So pass along those ideas and the people that you want to see. And that is about it. So thank you, Mark, again. Thank you for giving your time. We really appreciate you. And we'll say goodbye.
Yeah. Bye, everybody.
Bye, folks.
Bye.